Well, I was watching a video of a guy trying to prove a solution um, to a quadratic equation when a is equal to zero when using the quadratic formula. However, there were a few flaws that I saw in that video, and one of them was the first is that when a cannot be equal to zero to be a quadratic equation. So his analysis right from the beginning, you cannot call a quadratic equation if a is equal to zero, because when a is equal to zero, this term will not be here, and you're just going to be left with a lineal equation in the form of b of x plus z equals zero. And this is if a is equal to zero. So hence that's why a, the value of the coefficient, cannot be equal to zero. Now we know that a quadratic function is in this form, a quadratic equation is in this form, and when we have in this form, in the standard form, let's call the standard form, we can find solution using different methods. One of the methods is using factoring, where we factor the quadratic equation into two binomials, two linear binomials, and then we use the zero product rule to find the roots or the zeros of the equation. And notice that we get the quadratic equation when f of x is equal to zero. So if f of x is equal to zero, we get the quadratic equation, and then we can solve. However, we could solve for any value of f of x. So if f of x is equal to 5, we just have to rearrange it to standard form to be able to find a solution for x for that particular value of f of x. So it really doesn't matter, but like when f of x is equal to 0, we get a standard form. So we can also complete the square. And one of the methods that I like is the quadratic formula. So if a is equal to 0 in this case, and the analysis that he was arguing is that we have to use the limit when a approaches infinity, and then we'll have to use a method to not have a in the denominator. And in the end, he arrived to these two solutions. X is equal to minus c divided by b, and infinity. And the thing is with infinity is that infinity will not satisfy the equation, this equation, because if you have a very large number, that large number will never be equal to 0. So infinity, if you use a quadratic formula to try to argue that you can find a solution when a is equal to 0, you are wrong at this point. He was wrong at this point. At this point, infinity has to be discarded because it will never satisfy this equation. The only solution to this equation is this. This one satisfies the equation perfectly to be equal to 0. So, and again, the definition of a quadratic formula, and you can see here, this is my book. It's the Paris Chemical Engineer's Handbooks, the 7th edition. You can see it here on the chapter of Mathematics 314, and it explains what linear equations are, and it explains quadratic equations. Every quadratic equation in one variable is expressible in the form ax squared plus bx plus c equals 0. A cannot be equal to 0. This equation has two solutions, say x1, x2, given by, if a, b, and c are real, the discriminant b squared minus 4ac gives the character of the roots. If b squared minus 4ac greater than 0, the roots are real and unequal. If b squared minus 4ac less than 0, the roots are complex conjugates. If b squared minus 4ac equals 0, the roots are real and equal. So that's something to keep in mind. So the analysis of that person, I will say, that was bad. That was a wrong mathematical analysis we was doing for a is equal 0. And in all honesty, I don't even know why I watch it, but stuff like that makes me so mad that it's even that can be found on YouTube, honestly, because you cannot call a quadratic equation when a quadratic equation if a is equal to 0. If a is equal to 0, you just have a lineal equation, period. And I get it. Maybe he was trying to use mathematical analysis to find something different, but like his analysis just fell off. And especially when he arrived to solutions and he didn't even check to see if that solution was actually make sense. And his solution of infinity it just doesn't make sense. Again, doesn't satisfy the original equation. So even if he was taking the limit, it was just a bad mathematical analysis in my opinion. And as such, I recommend not watching that video because honestly it's just full of bad math. Anyway, that's all I got. Have a great day.